Hello, my name is Martin. Today I'll be talking about the Euler's method and how we can use this method to estimate the solution of an initial value problem. What is the Euler's method? The Euler's method is a simple numerical technique used to approximate solutions to ordinary differential equations when an exact analytical solution is difficult or impossible to find. It works by taking small steps along the slope defined by the ODE, building the solution incrementally. Firstly, I'll explain the formula. Yn plus 1 is the next approximate solution value. Yn is current solution value. H is the step size. F of xn and yn, or dy dx, is the slope at the current point. And xn is the current independent variable value. As you can see, there's three columns, each for x, y, and dy dx. For when x equals to 0, y equals to 1, and dy dx is the given OD here, x squared plus 1 over y, where cells B14 and C14 are x and y respectively. Given the IVP, we need to solve y when x equals to 1. Hence, using the step size 0.2, we can approximate that y equals to 1.9094791. Now, I've done calculations for two other different step sizes, 0.1 and 0.5, 0.05, to show you the difference it makes in approximating your value. Here, you can see that when your step size is 0.2, your approximate error, which is the exact value minus the approximate value, is 0.55%. As you can tell, when using a smaller step size, my approximate error percentage goes down. For this IVP, I will definitely use a smaller step size. However, what are the implications? I will answer that shortly. First, let me show you how I derive the exact solution. Firstly, separate the variables on the left and right hand side. Take the integral on both sides and apply the initial condition of when x equals to 0, y equals to 1. Doing so, you get c equals to 1 over 2. Substituting value of c and solving for y, you get this equation. Now, input when x equals to 1, your final answer is y equals to 91485. Rounded off to 3 decimal points, 1.915. Now, these are plotted graphs using data taken from the previous table. Comparing the approximate and exact value, you can see that when h is a smaller step size, you get an approximate value that is closer to the exact value. However, there are some cons to using a smaller step size. When your h is equals to 0.2, the process you have fast progress, covers more ground quickly, is time efficient. However, you miss crucial details, shallow understanding, and higher error risk. When your H is 0.1, you get solid comprehension, efficient time use, captures essentials and good accuracy. However, it is slower than surface approach, requires more focus than skimming. And lastly, when your H is 0.05, you get maximum thoroughness, very low error rate, complete coverage. However, it is extremely time consuming. It has diminishing returns and potential burnout. Thank you.